In this lesson, we shall focus on mathematics 1B, Math 141 tutorial 9, and we shall be looking at problems that need to be solved pertaining polar coordinates, conversion of polar coordinates to rectangular coordinates, and we begin as follows. Right, to start with, we are looking at actually 7A, because we did up to last time the whole of 6B and the other questions that came before. So we're looking right now at 7A. Identify the curve by transforming the given polar equation to rectangular coordinates. Now, looking at 7A, then you have r equals 4. Right, now, given r equals 4, this one here is a polar equation. And this polar equation needs to be transformed into a rectangular equation. And so you need to just remember that r always is the same as the square root of x squared plus y squared equals 4. In other words, you need to remember that r squared is x squared plus y squared. Or alternatively, r becomes the square root of x squared plus y squared. The sine of theta is opposite of hypotenuse. Cosine theta is actually adjacent over hypotenuse. And this is consistent with what you call SOHCAHTOA. SOHCAHTOA. And hence, when we have this, we can square both sides of this with x squared plus y squared. Which means x squared plus y squared is actually 4 squared, and 4 squared is 16, and this is the correct answer. And this is the correct answer. Any question about this? Any question about this? So we've been able to convert a polar equation r equals 4 to what you call a rectangular equation. Right. Well, this pertains what you call rectangular. It pertains what you call rectangular equation, or it pertains what you call rectangular coordinates. Rectangular coordinates. Right, so that's what we're able to see. Make sure that you understand what is happening.
Sorry.
Yes, please.
So every time you have to use this method of
Yes.
like circular whatsoever.
Yes, most definitely. Every time we need to use this method. So there are basically 3 popular equations we use. We use r squared equals x squared plus y squared. Sine theta is actually y over r. Cosine theta is x over r. And we also use tan theta is y over x. Right, so with this, simultaneously, when we do these things, we actually do them in relation to this here, which is r, y, and x. So we use that right angle triangle there to be in a position to solve problems that pertain conversion of polar coordinates to rectangular coordinates and vice versa. And vice versa. Right, so we then continue. You then are able to continue. Let's look at the next problem. Right, the next problem is the second Roman figure. Right, so the second Roman figure is not at all different, it's just the same. So how do we convert that one, which is just the same? Right, how do we convert that one, which is just the same thing? Right, we have to convert it to rectangular coordinates, but it is exactly the same thing. So to convert it to rectangular coordinates, a couple of things we need to take into account. We just need to substitute we can just cross multiply, you know. I mean, there are many ways to actually do it. So in the, okay, first we can have this one. Right, to deal with that one, we are going to deal with r equals 3 sine theta. And so the sine theta, as we said already, is opposite of hypotenuse in this triangle. Okay, so you have put sine theta is y over r, and then we cross multiply, we get r squared is 3y. If this is the case, then you continue with the substitution of x, but you need to know that r squared is x squared plus y squared. At this point, then it is very clear that what we're able to achieve, r squared is x squared plus y squared, which is 3y. Which is exactly 3y. So we are done. We just have to complete the square. So you have x squared plus y squared minus 3y equals naught. So which means that we then are able to achieve completing the square. It's x squared plus y squared minus 3y. We take the coefficient of y, which is negative 3. We divide it by 2 and we square. We do it on the right-hand side as well, which is y minus 3 out of 2. We square it, and if we square it, negative 3 out of 2 becomes 9 over 4, which is exactly this. And therefore...
Sorry.
Yes, please.
Why do we also do it on the other side?
Because when we add anything to an equation, whatever we do on the left must be done on the right, and that is the law of equations. Okay, because we're given an equation, and we added minus 3 over 2 squared on the left, and we need to do it on the right as well. Because it is the law, the algebraic law of equations. And any equation, if it's transformed, whatever you do on the left is always supposed to be done on the right. It's supposed to be done on the right. So any question?
Sorry, I got lost in the second part. You see where you wrote r is equals to 3 sine, and then the next step, r is equals to 3. Oh, you used, okay, I think I see it. And then the
Okay.
R's cancelled out or something. What happened? Or you multiply. Oh,
We
cross
cross multiply.
multiply.
Good, because what is sine
Mm.
theta? So there are three formulas we use. Sine theta is y over r in view of SOHCAHTOA. Cosine theta is adjacent of hypotenuse. Tan theta is y over x. So we use this equation. So sine theta is what? Is y over r. So wherever there's sine theta, we put y over r. And then we cross multiply at this point. R times r is what? R times r is r squared, which equals 3y. But we also use the fact that always r squared is x squared plus y squared. R squared equals x squared plus y squared. R squared is x squared plus y squared. Any question? Any question? Any question? Any
Sorry.
question? Yes, please.
You see, after completing the square,
Yes.
and where did we take the 3y, the negative 3y to?
This negative 3y. Okay.
Yes.
It's because when you complete the square, you look at this here. And when you look at that, you only write y. And then you write the minus 3 over 2. And then you make it becomes a perfect square. Because when you expand this, it produces the three terms. Because when you have the y minus 3 over 2 squared, you say y squared. Then next is y times minus 3 over 2 times 2. You know? In the same way that with the law of squaring, y minus 3 over 2 and then y minus 3 over 2. Y times y is what? Is y squared. Y times minus 3 over 2 is minus 3y over 2. Minus 3y over 2 plus 9 over 4, which is y squared, this and this. Minus 3y plus 9 over 4. So it would be correct, therefore, to then say, whenever you're completing the square, you write the y, and then you write the minus 3 over 2, and you put a perfect square. Because whenever you have the perfect square, then you have the minus 3y. It's going to come out of the binomial expansion of this. If you expand this, you multiply out, you get minus 3y, and there's going to be a 9 over 4. That's going to appear there. But simultaneously, you have the 9 over 4 on the right, so the 9 over 4 sort of cancel out. Make sure you understand these. 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 Okay. We can do it again. Right, doing it again, this Riemann figure 2, we start with r equals 3 sine theta. We're starting from scratch. But because we have sine theta, what is sine theta? It is y over r, always. And so, which means that r is 3y over r, and then we cross multiply. When we cross multiply, we have r times r, which gives us what? R squared is 3y. But what is r squared? Always. R squared is x squared plus y squared. The sine of theta is y over r. So we have this. We have exactly that. So that is what we have. That is what we have. So we have x squared plus y squared minus 3y equals 0. We have the coefficient of y, which is minus 3. We divide it by 2 and we square. And we do that on the right-hand side as well. And we then have x squared plus y squared minus 3y plus negative 3 out of 2. You square it. And you have the negative 3 out of 2 on the right. This is x squared plus y minus 3 out of 2 squared, which is 9 out of 4. So now the binomial square all squared produces a trinomial. So this trinomial means three-term expression. The three-term expression, now when expanded, produces a binomial in perfect square form. Any question? Any question? Make sure you understand these things. Make sure you understand these things. Right, make sure you understand these things. Right, right. Right, 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 right. Any question? Right. Right, 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 right. Okay, we continue. We have this one also, which is the third Roman figure. If you have r equals 8, divided by 2 cosine theta plus 3 sine theta. So then what exactly do we have here? There are a couple of equations we use, so we're going to put everything in this, but we also know that x is r cosine theta. Or you can say the sine of theta is y over r, cosine theta is x over r. So this one is x over r, y over r. That's what we have. So we can cross multiply these things. So if you cross multiply this thing, it becomes r 2x over r, y over r equals 8. So if you multiply out, it becomes 2x plus 3y is equal to 8, which is this one here. So we have therefore been in a position to just substitute the x, which is the cosine theta, which is x over r, the sine of theta, which is, the sine theta is y over r, the cosine theta is x over r. X squared plus y squared is r squared. Right. 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 So we continue. Right, we continue. Right, we continue. We continue. So we've been able to solve Roman figure 3. Right. Right, 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 right. Right, right, right. Right, 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 right. Okay, we're already done. We continue. We continue. We continue. Right, so we have been able to show that the Roman figure 3r equals 8 divided by 2 cosine theta plus 3 sine theta is actually a straight line. So we've been able to convert that to a straight line equation. Exactly to a straight line equation. That's what we've done. That is what we have done. And so that is what we have done.
Every single day.
Right, so we continue. We continue. We continue. So we continue to the next one, and the next one is what? The next one is a fourth Roman figure. Right. Let's check it out. Let us check it out. So if you deal with tan theta, secant of theta, right. The tan of theta is y over x. And so the cosine of theta is x over r. And we know that sec theta is 1 over cosine theta, which is r over x. R over x. So to actually therefore convert this one, we're going to do substitutions, and then we have r, the tangent of theta is y over x, and the secant of theta is r over x. So we get exactly these here. So what exactly do we achieve out of this? We can write r is 4yr divided by x squared. Which is rx squared, 4yr. Right. 4yr. So we continue. Right. Right. We continue. Because R is not 0, you can write this minus 4y R is 0. You can factorize R minus 4y minus 4y is 0. But the radius is not 0. So that we have that is the case. R is not 0. And what we have is that R is not 0, yet x squared is 4y. You divide by 4, getting y equals a quarter x squared. So this is exactly what we have. So y equals a quarter x squared. We divide by 4 here, and we get that y equals 1 quarter of x squared. And that is what is there. So any question about that one? Any question about that one? Right. 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 So we continue. So we have solved all these problems up to 7. So make sure you understand exactly how to deal with these problems. How to deal with these problems. Right. Make sure you understand how to deal with these particular problems, and we move on to the next question. Let us check what the next question is about. Okay, that was 7B. So we're done with 7A, and then there's 7B. Express the given Cartesian equations in polar coordinates. Right, so you have the following Cartesian equation. So let us look at B first Roman figure. We have y equals -2. Y equals -2. So if y is -2, then we have the following. And then we need to convert it to polar coordinates. But we know that the sine of theta is y over r. Simultaneously, we also know that y is r sine theta. Y is r sine theta. So that wherever there is y, we can put r sine theta. is -2, which is actually exactly -2. And therefore, want to solve for r, divide by sine theta, it becomes -2 divided by sine theta. 1 over sine theta is the cosecant of theta. Cosecant of theta. Cosecant of theta. So we continue. So we've been able to convert y equals -2 to polar coordinates. So this one was actually a Cartesian equation. And this obviously would therefore become a polar equation. A polar equation. This would therefore become a polar equation. And therefore, we look at the next thing. We look at the next question. Right, to look at the next question. Right. All right, so now we have a Cartesian equation converted to a polar equation. A Cartesian equation converted to a polar equation. Right. So we continue. So we continue. Right, let's look at the next one. We look at the next one. So the next one becomes what? So the next one becomes the second Roman figure. So we've been given x squared plus y squared equals 9. And need to convert it to polar equation, to polar form. But we know that r squared x squared plus y squared. X squared plus y squared is r squared, which is equal to 9. Which is equal to 9. Right. So continue. So we continue. We continue. So we continue. We continue. Okay, so if r squared is equal to 9, then we take the square root. And therefore r is 3. And therefore r is 3. And therefore r is 3. And we have been able to convert that equation to r equals 3, and r equals 3 is the required answer. And r equals 3 is the required answer. Any question? So now, after that, we move on to the next Roman figure 3. This one here. Equals 0. X squared minus 6x plus y squared equals 0. Right. So we continue. Right now, to convert this one to polar equations, we actually need to think very carefully and realize something. There is x squared plus y squared here. So you can group them together. X squared plus y squared is r squared. But x is equal to r cosine theta. So wherever the x is, you have r cosine theta. So you can pull out the common factor r. Minus 6 cosine theta. Which means r is not 0. R is 6 cosine theta. R is 6 cosine theta. And this is the answer. R becomes 6 cosine theta, and that is the answer. And that becomes the answer. So we continue. We continue. Obviously, please check these carefully and make sure you understand it. Right. We continue. So we continue. We continue. Right. So we've been able to solve Roman figure 3, x squared minus 6x plus y squared equals 0 is the same as r equals cosine theta in the rectangle in polar form. In polar form. In polar form. So continue right now to analyze the next equation. Analyze the next equation. Right, so then I have exactly the following. Let us look at Roman figure 4, this one. In that case, we have x squared with x squared plus xy plus y squared equals 1. So we do the same here. And we need to think about what we need to do to solve this particular question. What method we need to put in place? What methods we need to put in place? So we continue. Right, so obviously we need to think about what you need to do here, but we use the equations we know already. The couple of equations that we know already that can be used to actually solve this particular question. And so we continue with our analysis. And we look at what to do next in this particular question here. Right, we continue to check what to do next in this particular question. So now we have x squared plus y squared, which we already know. So we put these together. We have xy, we put them together, or x and y. All right, so, but we know that r squared is x squared plus y squared. That we know. But we know that x is r cosine theta, but also y is r sine theta. Those are the things we know. But we also know that whenever we see the tangent of theta, it is y over x. That also we know. So that x squared plus y squared is the r squared, and then x is r cosine theta. Okay, we add them up here. Which is r cosine theta. Which is r sine theta. Which is r squared, and then r squared cosine theta sine theta. So this is what we actually are having. So, which means that we're going to have, we have r squared, then we have r squared, then we can write sine theta, cosine theta is 1. And then it is 1/2. Okay, but first let us do the following. So we factor out r squared out of this. So r squared is a common factor, and we have 1 plus sine theta cosine theta equals 1, which is 1/2 2 sine theta cosine theta. Two sine theta cosine theta is sine 2 theta. So that is the answer to fourth Roman figure. Because we know already that always sine 2 theta is 2 sine theta cosine theta. 2 sine theta cosine theta. So that is what we have. So you need to think about what we need to do. Any question on this? Any question on these? Right, so any question on these? Need to make sure we understand what to do. Need to make sure we understand what to do. So we look at what to do next. We continue. We continue. Any question about this? Right. Any question about this question in B, fourth Roman figure? Fourth Roman figure. Fourth Roman figure. Fourth Roman figure. We continue to the next question. We continue with the next question. Right. We continue with the next question. Right, let us take a look at the next one. Let us take a look at the next question. Next question, what we do is we investigate and we check. We check the next question. We check exactly the next question. Let's see what to do next. Right, after that, it's question 8. Sketch the curve in polar coordinates. You need to sketch the curve in polar coordinates. You need to sketch the curve in polar coordinates. Sketch the curve in polar coordinates. So now we're looking at these. How do we then sketch the curve in polar coordinates? reason this out. So to sketch the curve in polar coordinates, we've been given theta equals minus 3 pi over 4. So if theta is minus 3 pi over 4, what do we do? What do we do? Right, so we actually need to see exactly what to do here. And we continue and analyze these cautiously and make sure we understand what we need to do in this case. To sketch, this one is an angle. So how do we sketch an angle, and what does an angle represent? And that is something that you need to think about. What does an angle represent? What does an angle represent? So, right, what does an angle represent? Okay. Right, obviously. There are a couple of things you need to take into account here, and an angle, if it's measured, it is measured from the positive real axis. Measured from the positive real axis, we're able to see exactly what we need to do. Right, so to draw these, sketch the curve in polar coordinates. So if you have these, obviously we are able to see clearly that minus 3 pi over 4 is a negative angle, so it's going to be measured like this, which is minus 3 pi over 4 radians. Right, and at this point, what does this obviously sure, it actually is can be seen as a line like this, a line just that way, a line that way, because also if you look at the fact that theta is minus 3 pi over 4, you can take tan theta here, which is the tan of minus 3 pi over 4, and this is tan theta equals the minus 3 pi over 4 is minus the tangent of 3 pi over 4. Now, 3 pi over 4 is the same as what? You have a pi over 4, 2 pi over 4 is like 45, and then 3 pi over 4 is here in the second quadrant, which the tangent is negative. And then it is negative 1 over the square root of 2. And then now you can actually be able to see the tangent is y over x is equal to 1 over the square root of 2, which is 1 over the square root of 2x. Okay. So now you can actually be in a position to see this exactly. Let us take a look at this and use a calculator. So if you take the tangent both sides, you're going to have the tangent of negative 3 times 45 degrees. The 3 pi over 4 is the same as 3 times 45 degrees, which is exactly a 1. Right, so So if this is 1, you can see it as tan theta equals 1. Oh, yes. So this is just a 1, then just a pi over 4. So it is exactly just a -1, etc., giving a 1. Check this out. So it's a minus, but that a -1, and therefore it is a 1. So what then this shows is that we actually have the line y equals x associated with this. Okay, let us check these very, very carefully. We check these very carefully. So obviously this would be, what would be the associated angle of these? Right, what would be the associated angle of these here? So now, we have the tangent of minus, 3 times 45, which is 1. 1. So that y is x. Right, so that y actually becomes exactly x. So then if this is the case, oops, okay, so this is supposed to be sketched here. Okay, this is supposed to be sketched here. Okay, so if you look at it very carefully, minus pi over 4, minus 2 pi over 4, minus 3 pi over 4 should be here. So therefore, this should be seen as this, because it's minus 3 pi over 4, so it is the same as the line y equals x. Right, so you can actually sketch it as theta. You've got minus 3 pi over 4, but you can sketch it as y equals x. Think about it. But that is the answer. And the line y equals x is exactly that one there. It's exactly that one there. You see, I can see what they've done there, but in 8a, I can see what they've done there. But if you check carefully, you're able to see that it is something hard. Okay, it is something interesting, but but looking at your tarts, I'm looking at your tarts, the tart 9, to see what they've done, but okay, looking at your tart 9 and what they've done, they've done something, and if you look at the sketch they've given, I'm trying to compare with your tart, so I'm actually looking at what you sent on WhatsApp, but yeah, I'm not opening it on the system because it's going to disturb our progression. It's going to interrupt our progression. It's going to disturb. Yup. Right. You see, that is the thing. Is it the same answer if this one is running down like this and this one is running up like this? You know, that is what I'm posing for. That is what I'm stopping for a moment. Because, yeah. You see, that's the thing. Is it because of the negative? Because, you see, I'm stopping because the line they've given is running down slope, yet it must run up slope. So that is why I stopped. 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 Okay, because theirs is running downslope. Sketch the curve in polar coordinates. Okay, this curve is in polar coordinates. So now, if it is in polar coordinates, theirs is running downslope. But negative 3 pi over 4, if you measure the angle very well, I mean, it's like negative 45 degrees 3 times. So 45 degrees is like halfway here. Negative 45 is like here. Another 45, because 45 it's like here. 45 plus 45 is 90 degrees, putting it there. So the messages, this one is 0, and this one is pi over 2, which is the same as 90 degrees. This one is 180 degrees, which is the same as pi radians. Like this. And then this one is 2 pi 360 degrees. Okay. So if you look at these, then there is an issue. Right, there is an issue with the way they've drawn this one. So I'm looking at it personally and I'm like, okay, they've drawn down slope, but it has to run up slope. So need to check it out. Need to check it out. Need to check it out. Right, you need to check it out. Right, you need to check it out. All right. Need to check it out. But you're able to see that they've drawn theirs to run down slope, but yeah, because it is, then they've not drawn the correct thing. Because I've drawn it in two ways. This is the y-axis and this is the x-axis. So we can also convert it from the polar coordinates to rectangular coordinates. And if you take the tan both sides, the tangent both sides, you have the tangent of minus 3 pi over 4, it becomes a 1. And then this, the tangent is y over x, and therefore this means that y is equal to x. Right, so we continue. Right, we then are continuing. But yeah, I'm looking at this very carefully, and I'm looking at therefore how they've sketched it. Right, I'm looking at how they've sketched it. Right. Right. Right, 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 right. Right. And so, yep, you're thinking? Okay, let me check your chat. Okay, good. We'll come back to it later because, yeah, I was just looking at it, but yeah, it didn't make me happy. Didn't make me happy, so I just stopped to then say, okay, let's just check carefully because, yeah, the angle of minus 3 pi over 4 is this one. Negative angles are measured in a clockwise direction. Okay, let us look at part B. We need to sketch this one in part B. Right, so part B tells us that with R is 5, radius is 5. This is exactly that. So if we need to sketch radius 5, well, there are different ways to sketch it. Because you know that R is the same as the square root of x squared plus y squared, which is 5. You can just sketch it like that. X squared plus y squared, and then 5, you square both sides. You note that. Meaning if x squared plus y squared equals 25. Okay, we can write this x squared plus y squared equals 5 squared. So you have y and then x. Like this. So this is a circle centered at the origin of radius 5 units. Like that. Right. 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 So we continue. Okay, so that is the answer to that one. Radius 5 can be sketched like that, but obviously radius 5 has to do with radius equals 5 has to do with a circle centered at the origin of that radius. at that radius. At that radius. At that radius. So look at the next question. And the next question is C, part C. R equals, yeah, so you see the thing is that with part B, you can see the answer is the same, yeah? This circle is the same as the answer because the answer is already there. So I've just obviously just explained how the answer is obtained. Okay, let us look at part C right now. Let us look at part C. Right, if you look at part C, what you're able to achieve? 9 sin theta. Nine sin theta. Nine sin theta. Right, R equals 9 sin theta. We actually can be able to deal with this one, but yeah, there are a couple of ways to sketch it as well. But how do we actually obviously get to sketch this one here? We actually obviously can sketch it by looking at a couple of things. To sketch it, we can look at the fact that R, wherever we see R, it is the square root of x squared plus y squared. This one is, the sign is opposite over hypotenuse, which we can do it like this, but we can also write as follows, yeah? You can also say, if you check, R is 9, and then the sine of theta is y over r, opposite of hypotenuse. We cross multiply, we get r squared is 9y. Wherever you see r squared, it is x squared plus y squared is 9y. X squared plus y squared minus 9y is 0. And then we'll be able to get what we need. What do we need? So you have x squared plus y squared minus 9y. And then we look at the coefficient of y, it's negative 9. You divide it by 2, you square it. But the same must be done on the other side, which is x squared plus y minus 9 out of 2 squared, which is 81 out of 4. Okay, so you can also write it, as x squared plus y minus 9 out of 2 squared. It is 9 out of 2 squared, which is descriptive of the fact that it has center x is 0 and y is 9 out of 2. And then the radius is, the radius becomes exactly 9 out of 2. So the center becomes 9 out of 2, and then the radius becomes the same. So as a consequence, You have 9 out of 2. You have exactly 9 out of 2. We're going to do this. Nine out of 2. That is it. That is 9 out of 2. That is the circle there. So obviously it has a radius. It's a circle. Center 0.9 over 2. Radius equals 9 over 2 units. 9 over 2 units. So y'all take a look and think. Take a look and think about it. Take a look and think about it.
This is Mr. Mpuno from Polybet. Good morning, good people.
Right, so we continue.
This is Mr. Mpuno from
We continue. Right.
As much as we are still on the process of doing the free lesson this week, but I would like to announce this to every learner who wishes to be a part of.
So think about it and make sure you understand it.
Even in the following week.
Right.
As much as we know that maths and physics, it's 150 each subject, then at 350 both. But I'm going to take first 5 people by 250 both maths and physics. But if you wish to do one, then I'm gonna take you.
So we continue.
Subjects, first 5 people.
So we continue. So we continue. Okay, so we've sketched this one, so this one corresponds exactly. So yeah, it's fine. But because at this point, then this is 0 here, then this one is going to be like 9 units. It's going to be like 9 units there. Because it's 9 out of 2, and then here it's the 2 of the 9 out of 2. So up here is going to be the 2 of the 9 out of 2, and this is 9. Yeah, 9. Exactly a 9. Now, so think about it, and make sure you understand the solution. Here's, we shall move to the next one, and look at exactly what needs to happen there. Look exactly at what needs to happen there. Right. Look at what needs to happen there. Look at what needs to happen there. Need to look at what needs to precisely happen there. Let us reason this out to make sure we understand what needs to happen. And then we move on to the next question. Let's look at the next one. D. Let us look at D. So D is that one. Right, so obviously we have the following. Right. Now, in part D, you have been given. Right, we have been given r equals 2 theta. Theta is a positive angle. Theta is a positive angle. Right, it is actually a very positive angle. So if theta then becomes a positive angle, then what is the meaning of this? Then we need to sketch. We need to sketch the curve very carefully. Right, we need to sketch the curve very, very carefully. So, right. So now the couple of things then we need to obviously think about in this case. The question becomes, how do we sketch this particular equation? How do we sketch this particular equation? So it actually sort of shows a curve as drawn there. Right, so it shows a curve as drawn there. And so we're asking the question, how do we sketch this? How do we sketch these? Okay. So to sketch these, you need to think, but like extra carefully. So now, whenever there is theta and then there is r, let us deal with theta equals 0. 2 times 0 is 0. Let us deal with theta equals pi over 2. You multiply by 2, it becomes pi. The theta equals pi, you multiply by 2 is 2 pi. Theta is 3 pi over 2, multiply by 2, you get 3 pi. And then you also have theta is 2 pi, you multiply by 2, you get a 4 pi. If theta is 3 pi, you multiply by 2, you get exactly 6 pi. You know. Okay, these are just some some angles that we chose randomly. But yeah, we can move instead of pi over 2, then we have pi, then we have 3 pi over 2, then we have 2 pi, and then we have pi over 2 plus this. So pi over 2 plus this would be, you can write it first, you can just put another angle here. Just moving in steps of pi over 2, then you have 2.5, which is 5 pi over 2. And then multiply by 2, it becomes 5 pi. And then you're adding the pi over 2 here, which becomes exactly 6 pi over 2, 3 pi. Multiply by 2, you get a 6 pi. Okay, take a look at this. So now the question then becomes, let us look at what this would essentially give us. Okay, at 0, 0, then we have the origin. Right, at 0, 0, then we have exactly the origin. If then we then say this is 0 and this is pi over 2 and this is 3 pi over 2 and this is rather just pi, radians, and this one is 3 pi over 2 and this one is 2 pi. Okay. Right. So we'd have exactly this one. So okay. Okay, now let us check. So if the angle theta is pi over 2, then, and we wish to sketch this, for instance, at theta equals pi over 2, you have that the r is pi. So you have the origin, but at theta equals pi over 2, then you have that the radius is pi. At theta equals pi, then the radius is, for instance, 2 pi. So at theta equals pi over 2, which is here, then you'd have that the radius is 2 pi. If the radius is 2 pi, obviously here you'd have to take minus 2 pi. Because 2 pi is going to be a number that is on this side. So this gives us this curve here. It gives us this curve. At 3 pi over 2 radians, then we have the radius is 3 pi, but you'd have to take negative 3 pi because you're on the negative side. Yes, yeah, the pi is the usual radian measure. So the radius pi becomes about 3.14. Yeah, you're right, 3.14. Here's the pi. So shift pi 3.14. 3.14. Okay, let us deal with 2 pi. Radius is 4 pi. At 2 pi, which is this one, the radius is 4 pi. So 4 pi is just going to be there. Yes. Yeah, based on this diagram. So it is the 3.14 that we use. So we use the 3.14. So obviously you can see that the minus 2 pi. Here, for instance, we're going to have 4 pi. So the 4 pi is 4 times these, which is like about 12 point something. Just thereabout. 4 times 3 is like 12 point something. So indeed, it is true that it's going to be further away from the origin. 2 pi is a bit further away, but 4 pi is far from the origin. Okay, let us practice more. Then we have 5 pi over 2, which is here, because there's also 5 pi over 2 here. So you go like pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. At 5 pi over 2, you have a radius of 5 pi. Radius of 5 pi. 3 pi. 3 pi angle. Then you have a radius of minus 6 pi. Well, the radius is 6 pi, but this side is negative. So this is the diagram. Okay, so this is how you would sketch the r equals to theta, theta greater or equal to 0. This is how you would sketch it. So any question on this so far? Any question on this so far? Any question on this so far? Right. Any question on these so far? Any question on these so far? So good. We've sketched a diagram, but yeah, our pi is 3.14. It gives a radius there. Gives some radius. Gives some radius. Gives some radius. It gives some radius. Gives some radius. Okay, any question? Any questions? So think about it and make sure you understand this. Make sure you understand these. So we'll sketch this diagram and then we're going to move to the next question, number 9. Let's check out number 9. Sketch the following polar graphs. In each case, state the values of theta for which r is a maximum, Roman figure 2. That's Roman figure 1 maximum, Roman figure 2 minimum, and the third Roman figure 0. Okay, yeah. Let's take a look at this one and make sure we understand it. And make sure you understand it. and make sure I understand it. Okay. So now let us deal with 9a. Now to deal with 9a, there are a couple of things you need to take into account. We have been given r equals 3, 1 minus sin theta. Okay. Sketch the following polar graphs. That is the instruction. Sketch the following polar graphs. In this case, state the values of theta for which r is in maximum, or r is maximum, minimum, 0. So to actually sketch this graph here, we do like we did. We do like we did before. The sine graph is an exciting graph. So what you're going to do, you draw a little table like this. And then there is theta, and then there is r as well. Let's start with 0, the origin. Okay, let's start with r equals 0. But again, it's not just that the angle theta equals 0 that we start with, but you can have some negatives also. Let us start with negative 2 pi. The sine of negative 2 pi is 0, giving us radius 3. And then we have minus 3 pi over 2, the sine of which becomes a 1. 1 plus 1 is 2, giving us 6. Then we're going to have the minus pi. The sine of minus pi is 0, giving us radius 3. And then we have minus pi over 2 radians. 2, which is 6. 0. Okay. And the sine of 0 is 0, giving us radius 3. Then we're also going to have pi over 2. The sine of pi over 2 becomes 1. So this becomes 1 minus 1 becomes 0. Pi radians. 3 pi over 2 radians is minus 1, giving us 6. Because if you put minus 1 at 3 pi over 2, the side of 3 pi over 2 is a minus 1. So you have negative 1 times negative 1 becomes, or rather, yeah, negative times negative 1 becomes a 1. 1 plus 1, 2, pi 3, 6. Okay, that's not what I mean here. I mean here is 3 pi over 2. 6. 2 pi radians. 3. Let us sketch this one and see what we've got. So, like we did before, so we're dealing with r theta coordinates. Okay. 0. pi over 2 radians. We have pi, 3 pi over 2, then 2 pi. But you can also go like this, clockwise, minus pi over 2, minus pi, minus 3 pi over 2, minus 2 pi. Okay. So now we can look at the positives first and the 0. Like at theta equals 0, the radius is 3. At theta equals pi over 2, the radius is 0. So you'd need another one pi over 4, because now we have 3 and then 0. But at pi over 4, what is the sign of pi over 4? It's 1 over the square root of 2. So you then have that r is 3, 1 minus the square root of 2 out of 2. Check it out. Okay, then you have the square root of 2 out of 2. Which is 0.88. 0.88. So which means that at pi over 4, which is here, you would have 0.88. But you see the 0.88, it's somewhere there. 0.88 is the radius. So which means that at 3 pi over 2, you're going to have that. Then you're going to have this one. So we continue. Right, we continue. Now we're gonna get here, but at pi over 2, then the radius is 0. But at pi, the radius is 3. Pi is here, but we're gonna take negative 3. Okay, we're gonna take, because also you'd need another angle here. Pi over 2, then there's also 3 pi over 4, because it's pi over 4, 2 pi over 4, 3 pi over 4. Bigger than pi over 2. Yeah, so it is 3, 1 minus the sine of 3 pi over 4. Okay, so let's use the calculator. Can estimate it. The 3 pi over 4. Okay, which is 3 times 45. 345 degrees. I've set the calculator in degrees. Okay, whatever, but there's a closed bracket there, which is minus 0.88. Is it minus? It's not, it's positive, yeah? Let's see. Yeah, it is 0.88. So here you have 0.88. So which means that when the angle is pi over 2, then you have 0.88 is this one. So it's going to match with the 3 pi over 4. 3 pi over 2, the radius is 6. Quite big. But obvious the radius is 6 and 3 pi over 2, but you're going to take a negative. Okay, so you're going to need another angle there to be sure. Because, I mean, we wish that it will go there, but you need an angle here. The angle here is going to be like 4 pi over 4, 5 pi over 4. 6 pi over 4, 7 pi over 4. So you're going to do r equals 3, 1 minus the sine of 5 pi over 4. But you also have r equals 3, 1 minus the sine of 7 pi over 4. Let us do these. 3, 1 minus the sine of 5 pi over 4. Okay, 5 pi over 4 you can write 5 times 45 degrees. Which is 5.1. Which is 5.1. And then the 7 pi over 4 would be what? Okay, yeah, I can see the time is after 8. So, you see, if you look at the 7 pi over 4, then you have the sine of that. So, it's going to be 3, open bracket, 1 minus the sine of 7 pi over 4, which is 7 times 45 degrees. Which is 5.1 still. So, it is symmetry. So the same distance, the distance is the same as the distance there, the same. So it is 5.1 distance, 5.1 units. Right, so it gives us exactly this shape. Okay. Gives us the shape of a heart. Right. It gives us the shape of a heart, a clean heart. So this is the shape we're getting, and I can see the time is 7 after 8. Okay, yeah, and then I can see that we're supposed to grab 8. We still have time, but we're trying to prepare for the maths test. So we are trying to make sure that we are aware of the things that must be done, and how to sketch everything else. So now we actually have the following shape. We have the following shape. We have the following shape. Right. Okay, so right. So you continue. Right. We actually have this. This curve has a special name. It has a special name. We call it a cardioid. It's called a cardioid. Or if you want to call it a cardioid, then we say it is heart-shaped. It is the heart-shaped polar curve. Right, I don't know how you're doing time-wise, but I feel that we've done something on the polar curves, and obviously we can continue. But I feel that we need to take a break. I know maybe you're still very energetic. We've been very relaxed in doing these questions. We're not running. We took our time going through each detail, and it was very, very awesome. So think about it and make sure you understand what is happening. Think about it and make sure you understand what is happening. Think about it and make sure you understand what is happening. Any question? Right, in the absence of a question, I think we shall take a break, and you let us know during the day if you're free, and we can continue doing more problems because there are lots. I mean, we've just done, we've just done 8, but there are many. Right, good. So we'll let you let us know. Otherwise, we meet during the day or in the evening time. Or we meet at 4 a.m. again, something like that. But yeah, we'll hear from you. But thanks a lot for joining us. Until next time, when you are free again, take care and goodbye. Goodbye.